In chapter 4.3, we're going to be looking at properties of logarithms. So there's going to be three main properties, the product rule, quotient rule, and power rule. And then we're going to be using those rules to either expand or condense logarithmic expressions. So starting with the product rule, so b, m, and n here are going to represent positive real numbers, and b cannot equal 1. So b is the base for this expression, and the base always, just kind of recall, the base always has to be positive, and it cannot equal 1. So the product rule is right here. It says that log base b of m times n, so things being multiplied, we can split that up and make it log base b of m plus log base b of n. So it's called product rule because the input is being multiplied m times n. You can split it up by giving each factor its own log base b and separate them by addition. So what this actually comes from is exponent rules for exponentials. So if we have b times n times b to the nth, we combine those by adding their exponents. So hopefully you can see how those kind of look related here. So going from left to right, this is how we expand logarithmic expressions. So let's do some examples with this. So let's use the product rule to expand each logarithmic expression and then simplify if possible. So we have ln of 7x, so hopefully by now we know that ln is log base e, the natural log. So ln of 7x equals, so they're being multiplied 7 times x, so it's going to be ln of 7 plus ln of x. So we give each one of those factors its own log, and we separate it by addition. Next one, log base 4 of 7 times 5. So 7 times 5 being multiplied, we can expand it by giving each one, 7 and the 5, its own log base 4, and separate it by addition. So log base 4 of 7 times 5 is 35. Log base 4 of 35 equals log base 4 of 7 plus log base 4 of 5. Okay, next one, log of 10x. So 10 times x, we can separate it. That's log of 10 plus log of x. So let's actually simplify this a little bit more. Log of 10 is equal to 1, because log without a base written is log base 10. Log base 10 of 10 equals 1, so that's 1 plus log x. Next one, we have log base 9 of 81y. 81 is being multiplied by the y, so that's log base 9 of 81 plus log base 9 of y. Log base 9 of 81, we can actually evaluate that. That's saying 9 raised up to what power is 81, so that's going to be 2. So 2 plus log base 9 of y is going to be our answer. Oops. Okay, and then an important note here, just so we don't mess this up in the future. Log base b of m plus n does not equal log base b of m plus log base b of n. Okay, so keep that in mind. We can't distribute the log base b into that sum inside of that input. So that is not true, so just don't do that. So that's the product rule. The quotient rule here, we have same requirements on b, m, and n. b, m, and n are going to be positive real numbers. B cannot be 1. The quotient rule says that if we are dividing two things in the input, we can split it up with subtraction. So log base b of m divided by n is going to equal log base b of m minus log base b of n. So what this one comes from is, once again, exponential rules. If we have b to the m over b to the n, that's going to be b to the m minus n when we combine them. Okay, and once again, this is how we expand logarithmic. It's one way that we can expand logarithmic expressions. So let's do some examples. So let's use the quotient rule to expand these. First one, log of x over 2. So we see division in the input. We know we're going to have some sort of subtraction. So it's going to be log of the numerator minus log of the denominator, because the 2 was in the denominator, so that log is negative. So log of x minus log of 2. and that's a base 10. Doesn't really matter in this case, but that's base 10 since it's not written. Next one, log base 7 of 19 over x. That's going to be log base 7 of the numerator minus log base 7 of the denominator. So log base 7 of 19 minus log base 7 of x. So always try to simplify some of these logarithmic expressions if they're just numbers. Log base 7 of 19 is not going to be a whole number because 7 raised up to thinking of it in terms of what it would be evaluated as, 7 raised up to an exponent equals 19. That's not going to be a whole number, so we're just going to leave it like that. Next one, ln of e cubed divided by 7, so it's going to be ln of the numerator minus ln of the denominator. Ln of e cubed, that simplifies to 3. So remember, that's the inverse property. Ln of e cubed, the ln and the e cancel, we're left with 3. So this is equal to 3 minus ln of 7. Last one here, log of x over 1,000. So it's going to be log of the numerator minus log of the denominator. So we can simplify the second term. That's going to be log of x minus log of 1,000 is equal to 3 because it's base 10. So it's saying 10 raised up to what power equals 1,000? The answer would be 3. And I'm just going to write a similar note here. We have to keep in mind that log base b of m minus n does not equal log base b of m minus log base b of n. Okay, so that's the product rule and the quotient rule. The next one is going to be the power rule. So same thing, b and m are going to be positive numbers and b does not equal 1. And r can be any real number here. Actually, that should say p. I'm just going to erase that real quick. That should say p. Okay, so p is going to be any real number. So this time for the power rule, obviously we're going to have some sort of exponent because it says power rule. Log base b of m to the p is going to equal p times log base b of m. So what that means is we take this exponent and it gets plopped down out front. And it gets multiplied. Okay, so let's do some examples here. So let's use the power rule to expand these expressions. First one, we have log base 5 of 7 to the 4th. So we see that there is an exponent on that input, which is 7. The exponent's 4, so we're going to bring that down front. It's going to become 4 times log base 5 of 7. Next one, we have ln of the square root of x. So we actually have to rewrite this as ln of x to the 1/2. So hopefully we remember that the square root is just an exponent, and it's an exponent of 1/2. So once we have that, we're going to bring down that 1/2. So it's going to be 1/2 times the ln of x. Okay, next one, log of 4x to the 5th. We have that 5, we bring it down front. It becomes 5 times log of 4x. So this rule hopefully seems pretty simple so far. Next one, ln of the cube root of x. So we have to remember that the cube root is an exponent of 1/3. So we bring that down out front and we get 1/3 times the ln of x. And for the last one here, for e, we have log of y to the -6. So we bring down the exponent of -6. That's -6 times log of y. Okay, so pretty simple rule. It's just a quick little mini one-stepper. But something important to keep in mind for the note for this one. Log base b of m to the p. What this equals when you write it like this, it's log base b of m to the p. The input is getting the exponent. this is not the same thing as log base b of m all raised to the p. So just kind of keep that in mind. Okay, so also one other thing to keep in mind here is when we use this power rule, we actually sometimes are changing the domain. So for example, if we have the ln of x squared, based on the power rule, we know that this equals 2 times the ln of x, right? We just took that exponent of 2, brought it down front. So if we took a look at the graphs for both of these separately, taking a look at y equals ln of x squared, and then taking a look at y equals the 2 ln of x, the ln of x squared is going to have a vertical asymptote at x equals 0, and it's going to look similar to what we have seen, something like that on that side, but it's also going to have the negative portion over here. So the reason it has the negative portion is because of the x squared. When we square the negative x values, it makes it positive, so it allows it to exist over there. So the domain here is going to be, it's going to be everything but 0. So negative infinity to 0, union 0 to infinity. For 2 ln of x, 2 ln of x is also going to have a vertical asymptote at x equals 0. It's going to have this side over here. Obviously, this is a rough sketch, so it's not going to be perfect. It does not have that left portion of it because we can only plug in the positive x values because that's the domain for logarithm. So the domain here is going to be just 0 to infinity. So the thing to keep in mind is that ln of x squared only equals 2 ln of x for x greater than 0. So that's just a small thing to keep in mind. It's not really going to come into play too often when we're doing these problems, but just kind of keep that in mind. So let's make these problems a little bit harder now. So we're just going to be expanding logarithmic expressions. So now we're going to be using all 3 of these properties to expand these expressions. So this doesn't always hold true, but usually most of the time it will. Perform the product or quotient rule first and the power rule last. Okay, so first one here we have ln of y cubed times z to the 5th. So we're going to do the product rule first because we have the inputs being multiplied. So this is going to be the ln of y cubed plus the ln of z to the 5th. So that was the product rule, and then we're going to be using the power rule and bring those exponents down front. So it's going to be 3 ln of y plus 5 ln of z. Okay, so that's as far as we can simplify it. So it was product rule and power rule, just one at a time. Taking a look at this next one, we have log base b of x squared times the square root of y. So I'm going to rewrite this as using the product rule. X squared times the square root of y, so that's going to be log base b of x squared plus log base b of the square root of y. And what I'm going to do next is I'm going to rewrite the square root of y as y to the 1/2. And then we're going to use the power rule. So we're going to bring down those exponents. So it's going to be 2 log base b of x plus 1/2 log base b of y. Okay, and then for next one here, we have log of x squared y divided by z cubed. So we have 3 different factors in here. We have an x, a y, and a z. So it's going to be the product rule and the quotient rule first. So the way that I think of it is I see 2 factors in the numerator, 1 in the denominator. The one in the denominator is going to have a negative log. So it's going to be positive log of x squared because it's in the numerator, plus log of y because it's in the numerator, and then minus log minus log of z cubed. And that one was minus because it was in the denominator for the quotient rule. So I just personally think it's easier just to do the product and quotient rule in one big step. And then do the power rule here. So bring down the exponent. So it's 2 log x plus log y minus 3 log z. And the next one here, we have ln of the square root of ex. So this is going to be the power rule first for this one. So it's going to be ln of ex to the 1/2. So now power rule, that's going to be 1/2 ln of ex. And now we can use the product rule. So it's going to be 1/2, and then parentheses, it's going to be ln of e plus the ln of x. So that's the product rule. And then next it's going to be, we have to recognize ln of e is equal to 1. So it's 1 plus the ln of x. So it's 1/2 times 1 plus the ln of x. I'm just going to distribute the 1/2 and get 1/2 plus 1/2 ln x. Okay, I'll do a couple more here. Log base 5 of square root of x over 25. So let's do the quotient rule first. So it's going to be log base 5 of square root of x minus log base 5 of 25. So log base 5 of the square root of x, that's x to the 1/2. And I'm going to do the power rule for the first term, log base 5 of x to the 1/2. Drop down the 1/2, that's 1/2 log base 5 of x. Log base 5 of 25, that's saying 5 raised up to what power equals 25? That would be 2, because 5 squared is 25. So that's the expanded version. Next one, log base 6 of 36 over the square root of x plus 1. So it's going to be quotient rule first, log base 6 of 36 minus log base 6 of the square root of x plus 1. So I'm just going to rewrite that square root as an exponent of 1/2. So log base 6 of 36 equals 2, because 6 squared is 36. I'm going to bring down the 1/2 exponent for the power rule for the second term, and this is our answer. So make sure you have parentheses around the x plus 1, because if you don't, technically it's something different. Okay, let's make them a little bit harder. ln of x cubed times square root x squared plus 1 over x plus 1 to the 4th. So we have three kind of main factors here. We have the x factor, x squared plus 1 factor, and x plus 1 factor. So we're going to have 3 different ln's. So it's going to be the product rule and the quotient rule. So it's going to be positive ln of x cubed, because it was in the numerator, plus ln of, I'm going to give the x squared plus 1. I'm going to change the square root to an exponent of 1/2 right now. And then it's going to be minus the ln of x plus 1 to the 4th, because that was in the denominator, so that one's negative. So this is all going to be power rule now. So 3 ln x plus 1/2 ln x squared plus 1 minus 4 times the ln of x plus 1. So being able to do everything in a couple things in one step is going to be a little bit easier. So for the next one, log base 6 of the cube root of x over 36y to the 4th. Okay, so we have 3 factors here. We have an x in the numerator, a 36 in the denominator, and a y in the denominator. So there's going to be 3 log base 6's. So it's going to be log base 6 of the cube root of x. I'm going to give it an exponent of 1/3. The next ones are going to be negative because they're in the denominator. So minus log base 6 of 36 minus log base 6 of y to the 4th. So next, for the power rule here, bring down the exponents, 1/3 log base 6 of x. Log base 6 of 36 is 2, so minus 2, and then minus power rule for log base 6 of y. Okay, and the last one, we have log of x cubed y to the second, all to the second. So we have two options here. We can either use the power rule right away on that 2, or we can give the exponent of 2 to the numerator and denominator and make sure we're using our exponent rules correctly. I'm just going to use the power rule first. So it's going to be 2 log of x cubed over y squared. Then it's going to be the quotient rule, so make sure you start parentheses. So 2 times log x cubed minus log y squared. Now I'm going to do the power rule, so it's going to be 3 log x minus 2 log y. And I'm just going to distribute that 2. So 6 log x minus 4 log y, and that would be our answer. Okay, so that's expanding logarithms. Nothing too crazy. You're just using the 3 rules, those 3 properties, and then keeping in mind that we can simplify some of them. So next, we're going to be doing condensing logarithmic expressions. So we're still going to be using all of these properties. It's going to be the same thing that we just did, except in the opposite direction as expanding them. So usually, but not always, we can perform the power rule first. We need to get a coefficient of 1 on the logs before we can condense them. And then we can do the product and quotient rule after that. So in order to combine these logs to condense them, we need to have the same bases on the logarithms. So doing some examples here, let's condense these. First one, we have ln of x plus ln of 7. So these are both ln, so we know we can combine them into 1. And we're going to combine them by using the product rule because of that addition. So it's going to be the ln of 7x, and that's going to be the answer. 7 times x. So product rule. Next, we have log base 4 of 2 plus log base 4 of 32. So we can condense them into 1 log base 4. So since they're being added, we're going to multiply them for the product rule. So it's going to be log base 4 of 64. Log base 4 of 64, 4 to what power equals 64? That would be 3. Okay, next one. 7 ln x minus 3 ln y. So this one we need the power rule first. So we need coefficients of 1. So it's going to be ln of x to the 7th minus ln of y to the 3rd. And since they're being subtracted, it's going to be the quotient rule. So it's going to be the ln of x to the 7th. That one's in the numerator because it was positive out front. And then the y cubed is in the denominator because it was negative out front. Okay. So log of 4x minus 3 minus log of x. So we have 2 logs here. 4x minus 3 is one thing. So combining these into 1 log, we have subtraction, so it's going to be quotient rule. So the 4x minus 3 is going to be in the numerator. And then the x is in the denominator because the x was negative out front. Okay, and the next one. We have 1/2 log x plus 4 log x minus 1. So we need coefficients of 1 first. So we need to use the power rule. So it's going to be log x to the 1/2 plus log x minus 1 to the 4th. So now we can do the product rule. So log of, instead of the 1/2 power, I'm just going to write it as the square root of x. It really doesn't matter though. Times x minus 1 to the 4th. So that's product rule. They're being multiplied because they were originally being added. Okay, we have 1/2 log x plus log y minus log z. So I'm going to leave that 1/2 being multiplied out front and then combine these into 1 log. So the x is positive out front, the y is positive out front, so they're going to be getting multiplied in the numerator. The z is negative out front, so that's going to be in the denominator. So it's going to be log of x times y divided by z. So probably easier than it looked for that one. Next one, we got 4 ln x minus 2 ln 6 minus 1/2 ln y. So we need coefficients of 1. So it's going to be the power rule first. So ln x to the 4th minus ln 6 squared minus ln y to the 1/2. So we can combine them all into 1 ln. So the ln of x, the x to the 4th is going to be in the numerator because it was positive out front. Those other two terms are going to be in the denominator because they're negative out front. So 6 squared is 36. Y to the 1/2 is the square root of y. Okay, so that would be our final answer for that one. Do another one, make it even messier. We have log x minus log 15 plus log x squared minus 4 minus log x plus 2. So all of these have coefficients of 1, well technically 1 or negative 1. So we can combine them. So the ones that are positive out front are going to be being multiplied in the numerator. So that's going to be x and the x squared minus 4. And the ones that are negative out front are going to be being multiplied in the denominator. So that's going to be 15 and the x plus 2. So we can simplify this a little bit. So hopefully we can see what we can factor here. We can factor the x squared minus 4 in the numerator as x plus 2 times x minus 2, difference of square factoring, divided by 15 times x plus 2. We can cancel common factors of x plus 2. So we get log of x times x minus 2 over 15. And I'll just leave it just like that. You can distribute the x in the numerator if you want. I'll just leave it like that though. Okay, so far we've done the product rule, quotient rule, power rule, and then we use those rules to expand and condense logarithmic expressions. The next thing what we're going to be doing is the change of base property. I believe this is the last thing actually. The change of base property, and we do this to evaluate logs. So before, when we were evaluating logarithms, we'd have something like log base 2 of 8, and we would say, well, 2 raised up to what power is 8? And then the answer was 3. So we were getting nice whole numbers for our answers, so they were pretty easy to do. Now we're going to be able to do this for other examples like log base 5 of 17, which is not a whole number, but we'll be able to plug it in the calculator and get a nice, maybe rounded answer. Okay, so the rule here is for any logarithmic base, a and b, and any positive m, if we're trying to evaluate log base b of m, it's going to equal log base a of m divided by log base a of b. So we can change the base, hence the name change of base property. We can change the base to base a, and then divide log base a of m, which is the input, divided by log base a of b, which was the base. So the ones that I'll be mostly using here are going to be ln or log, and that's because they're in the calculator. So this equals log base 10 of m divided by log base 10 of b, which the one that I always use is going to be ln. It's going to be the ln of m divided by the ln of b. So these are all equal. Or you could use log base 2 of m divided by log base 2 of b. And just like I mentioned, typically we're going to be using log base 10 or log base e. So log base 10 or ln, because those are on the calculator. So let's do some examples here. So let's evaluate using the change of base formula. So we have log base 5 of 140. So originally we would think 5 raised up to what power is 140? We know that 5 cubed is 125. 5 to the 4th is going to be 125 times 5. So our answer here is not going to be a whole number. So what we're going to do is the change of base property. So I'm going to use ln. This is saying this is equal to the ln of 140 divided by the ln of 5. So the ln of the input divided by the ln of the base. Plug this into the calculator, ln of 140 divided by ln of 5. I believe I had to round here, we got 3.07, which makes sense because I said 5 to the 3rd power was 125. So 5 to the little bit over 3 should be about 140. And I'll put over here, we could have used log of 140 over log of 5 equals the same thing, but approximately 3.07. Okay, next one, log base 3 of 5. So it's 3 raised up to what power equals 5. So we should know the answer is going to be about 1 point something, because 3 to the first power is 3, 3 to the second is 9. So I'm going to use ln again. So it's going to be the ln of the input divided by the ln of the base, ln of 5 divided by ln of 3. We get about 1.46. Once again, we could have used log base 10. Next one, log base 2 of 10. So it's going to be ln of 10 divided by ln of 2, which is going to be about 3.32. So that's saying 2 raised up to what power equals 10? 2 raised up to about 3.32 equals 10. For this one, I will write this one out using log base 10. So we could have done log base 10 of 10 divided by log base 10 of 2 instead. Log base 10 of 10 is equal to 1. So this would be 1 divided by log of 2. It looks a lot different than what we just had written out, but it's the same thing. Last one here, log base 1/2 of 8. So ln of 8 divided by ln of 1/2. Plug that in the calculator, and we actually get -3. So that's saying 1/2 raised up to what power? I'm just going to write this one in exponential form. So put check. In exponential form, this would be 1/2 to the x equals 8. So 1/2 to what power equals 8? So it should make sense that it's -3, because 1/2 to the -3 is going to equal 8 because it reciprocates it. It becomes 2 to the +3 equals 8, which hopefully looks more obvious. Okay, so for this whole section, we had product rule, quotient rule, power rule for logs. We use those to expand and condense logs. And then we also have this change of base property. So I have this little summary, which is in the notes, so just take a look at it. I'm not really going to go over it too much. We have the logarithmic definition, converting between logarithmic and exponential form. We have these properties of logs, and I have it in general with base b. I have it with base 10 and base e for the natural log. And then I have product rule, quotient rule, and power rule all in one spot here. Okay, so that is it for section 4.